Good morning, viewers. I am Inderjeet Singh, lecturer civil, Pandit J.R. Government Polytechnic College, Hoshiarpur. My qualification is BE Civil with honors from Punjab Engineering College, Chandigarh, ME Structures with distinction. From Punjab Engineering College, Chandigarh. My today's topic is foundation. Important part of the building foundation. This is a topic from third semester civil BC. Foundations. Lowermost part of any structure is called foundation. Now, if you see a structure, let us say I am having a structure like this one. This is my flooring. This is, let us say, a window. And a roof, of course. There are other partition wall. If you see the section, so this lowermost part is called foundation. This is very important while designing a foundation of a building. So, it depends upon the load coming on the structure. So, what type of loads, live load, wind load, etc. is coming. So, design is accordingly done for the foundation part. So, sometimes it happens we have designed a foundation for single story building and you construct 3-story or 4-story building, then there is a casualty that should be avoided. So, if you are having a overhead reservoir tank, that is also a structure and its foundation is likely to be designed for the given load. So, its foundation which should be strong, otherwise building may collapse. So, you are to give due consideration to the foundation part. Then purpose of foundation. What is purpose? Number 1, distribute load. So, if you are having some column and it is my foundation, load coming on this structure is properly distributed to this foundation part so that it can take up the loads. Number 2 is to transmit load equally. So, load is transmitted to the soil equally to prevent any lateral movement. So, wind load causes lateral movement that should be also checked. To secure a level and firm bed, foundation you are to secure a level. It should not be irregular surface, a plane surface, hard surface on which foundation should be resting. To increase the stability of structure, to increase stability of structure. Of structure. Now then, factors affecting selection of foundation. Number 1, what type of load is coming, whether it is a residential building or commercial. So type of loads are to be decided: live load, wind load, there are ice load also, if you are in some hilly area. Bearing capacity of soil, very important. Bearing capacity of soil, whether the soil is rocky one or ordinary one. So bearing capacity plays very important role in the design of foundation. Bearing capacity, the maximum load which the soil can take per unit area without yielding or displacement is called bearing capacity of soil. I am having some figures for various soil categories. So safe bearing capacity is given in kilonewton per square meter. Rock, number 1 is rocky strata. Granite is hardest rock, granite. Its bearing capacity 3300 kilonewton unit, same. Then sandstone, limestone. The bearing capacity of this one is 1650. Shattered, broken bedrocks. Broken bedrock. So this is having 900. Soft rocks which is having bearing capacity 450. Non-cohesive soils, here we are having compact gravel, non-cohesive soil, compact gravel, compact gravel is having value 450 again, and which is nearly same as soft rocks. Then we are having cohesive soils, bearing capacity, say bearing capacity in kilonewton per square meter. Cohesive soil, cohesive soil, medium clay, it's having bearing capacity 250. Soft clay, one thing I want to tell my students, that clay is very dangerous. When it is wet, then it is very bad, settlement is there, differential settlement is very fatal for a building. So, clay should be avoided. So, compare this one, the previous data. So, rock is having 3300 kilonewton per square meter, whereas soft clay is having 100 only. So, it is the underneath strata which is very important for the structure. Then we are having methods for finding out bearing capacity. Methods. Number one is my plate bearing test. And number two is method of dropping weight. Dropping weight. So, I will pick up first one, how this plate bearing test is carried out. So, we dug a pit for the plate load test, 5 times the side of a steel plate. Steel plate is sole plate, here we have a like this one. This size is 300 mm, 300 by 25. So, this is my pit, section of the pit. If timber bulk is placed at the center of this one, over that we are having a platform for loading. We load this with the increment of 5 kilonewton, and we observe the settlement coming in the foundation from this with the theodolite or level. So, here is gunny bags are placed in the form of load. Settlement is recorded when we find some settlement, then we apply the formula for ultimate bearing capacity of soil as ultimate bearing capacity of soil is W upon A. Load coming on that bulk and area of the sole plate. So, this way we find out the ultimate bearing capacity. Then we are having safe bearing capacity, which we use for design purpose. Safe bearing capacity. This is my ultimate bearing capacity. Bearing capacity over factor of safety, FOS or factor of safety, factor of safety. So, factor of safety is different for buildings, it is taken as 2. Factor of safety is 2 for ordinary buildings. And for heavy buildings, its value is 2.5 to 3 for heavy buildings. So, we do the design on safer side by taking factor of safety into account. Then we are having method of dropping a weight. Dropping a weight. Method of dropping a weight. So, in this case, we drop a steel rod. So, its weight is, let us say, W, H is the height of fall, weight of steel rod, weight of steel rod, then H is height of fall, height of fall, R is resistance of soil, resistance of soil, D is depth of penetration, depth of penetration, then R into D, R is my resistance of soil, D is depth of penetration. So, this must be equal to weight into height through which this steel rod is fallen. Then ultimate resistance, ultimate resistance will be equal to R is equal to W into H over D. Ultimate bearing capacity. So, what is then ultimate bearing capacity? This is nothing but ultimate resistance R over A, area. So, if you want to find out safe bearing capacity by this method, safe bearing capacity, then this load ultimate bearing capacity, let us say ultimate bearing capacity is my P, then this is P upon F, factor of safety. So, this way we can find out easily the safe bearing capacity. Then my next is topic is this one is method of improving bearing capacity, because foundation we know this bearing capacity is very important. So, how to improve this system? So, this is to be checked. Method of improving bearing capacity, method of improving bearing capacity. So, if your soil is having weak bearing capacity, then how we do it? First method is compaction. Madam, चल नहीं रहा, पेन चल नहीं रहा, एक ही गल हो गई, दूसरा पेन यूज करा, नहीं ये भी चलेगा ना, नहीं चलेगा. Method of improving bearing capacity, first is compaction. So, as you know, the soil is having maximum dry density at OMC, optimum moisture content, gamma D is maximum. So, this principle is applied over here, compaction. So, by compacting the soil, we can improve our bearing capacity. Then the second is draining the soil, draining. So, whether the structure is in earthen dam or building, drainage should be very much clear. Water logging should not be there, then even we can improve the bearing capacity of soil. Then third is you drive sheet piles. So, piles can be driven in certain area to improve the bearing capacity. Then cement grouting. This is done while maintaining our dams, cement grouting. There are cracks in the dams, then we do this one to improve the bearing capacity of those areas. By adding chemical, so chemicals can help in improving the bearing capacity. Chemicals, calcium chloride, dilute silicate of soda, dilute silicate of soda, or calcium chloride, calcium chloride. So, this way we can improve the bearing capacity of then we are having foundation types of foundation. One is shallow foundation. Other is deep foundation. When depth of foundation is smaller, then we go in for shallow foundation. Otherwise, when depth is more, in just like in the case of wells, we are having more depth, so deep foundation is there. Let us discuss about shallow foundation. Shallow foundation. In shallow foundation, depth is relatively less. So, it is having various types. Number one is spread footing, spread footing, very simple one. So, if this is your wall and you are having foundation like this one going through certain length, then this is called my spread footing. Let us say this block is 400 700 sorry. So, 200. So, this design can be carried out to find out these blocks dimensions. So, then we are having figures for foundation width. There is a sketch without plane projection and with plinth projection. Foundation without plinth projection